Hello. So welcome to part 1. So let's start with graphs. So I'll not go what is graphs here, you can read it somewhere else. So graph has basically, there are 3 ways to represent a graph: an adjacency matrix, an adjacency list, and an adjacency set. So in this video, part 1 will cover adjacency matrix representation of a graph. So I'll be using Jupyter Notebook as my editor. So I've started Jupyter Notebook. I'll in a separate video, I'll cover what Jupyter Notebook is, what are its advantages, and why I use Jupyter Notebook. You'll see most of those advantages over here, sir. So I've named it adjacency matrix. Okay. So the problem statement, step 1. Statement is adjacency matrix representation of a graph. I change into a markdown type. I do a shift enter. The pseudocode. Instead of pseudocode here, I'll share with you a diagram. So this is a graph. What you see here. So a graph is basically having 2 components. One are the vertices. Second is the edges. So vertices is, say you are talking about airline routes, so Seattle, Delhi, Hong Kong are the vertices, and the map, if there is a direct flight from Delhi to Hong Kong, there's a direct edge from Delhi to Hong Kong. So we represent the vertices in the graph as A, B, C, D and E, and it's a directed graph. So you have 2 types of graphs: a directed graph and an undirected graph. A directed graph means there's only a direction, an edge from A to B, there's no edge from B to A, unless I explicitly make another edge from B to A. So in this graph, there's a directed edge from A to B. What does 1 represent on the top? 1 is the weight of the particular edge. So right now, by default, I've kept all the edges as 1. So there's an edge from A to B, there's an edge from B to E, D to E, B to D, D to C, and A to C, all of weight 1. Now, how do I represent this particular graph in the adjacency matrix? So what we briefly do is, in adjacency matrix, we have a matrix of size V cross V. What is V? V is the number of vertices in the graph. So if there is an edge from a vertex Vi to another vertex Vj, we fill the element Vi colon j in the adjacency matrix. So say we have an edge from A to B, we say AB is 1. So AB is 1. AC is 1. So all the edges I have encircled in red. So we have an edge from A to B to A to C, B to D, B to E, D to C, and D to E. And all the remaining, which means there's no edge between those 2 vertices, I have represented as -1. So there's another thing as directed graph, and there's another thing as undirected graph. So if it would have been an undirected graph, the matrix would be a symmetric matrix, that it would be identical across the diagonal. So if you fold the matrix across the diagonal, you will find that every element overlaps. Okay, with that said and done, let's jump into the coding. So shift enter. This was a markdown, so throw an error, shift enter. So Python program. I'll be writing the program in Python, okay? So what does the first thing come into your mind? What are the 2 classes that you should define? One class should be a vertex, one class should be a graph. Why? Because the vertex will represent Seattle, Hong Kong, New Delhi, and the edges will represent the path from one to them. So I can add an edge. So first of all, there should be a class named vertex. There should be a class named graph. Cool. In a vertex, I should be able to assign an ID to each and every vertex. That's all. And I should be able to retrieve my vertex ID, and I should be able to fetch a vertex ID. So I'll define the initialize __ init self cool self dot id is equal to ID. So I need to pass ID. Okay, that's it. Apart from it, there should be a function to get the vertex, and there should be a function to set the vertex. Define get vertex. Correct. So get vertex will return me what? Self.id, the ID of the vertex. The another function will be set vertex. X. I make a lot of typos. What will set vertex do? It will assign the ID to my vertex. So I'll be passing an ID to it. Comma ID. I'll say self.id is equal to ID. That's it. That's all that are the functions that I need to define in my vertex class. Now let's move to the graph class. Now think about what all the graph class should be have. So look into this diagram. A graph class should have an adjacency matrix. It should have a list that contains all the vertices. It should have a variable that says these are the number of vertices. Like I have 5 vertices over here. Cool. So I'll say self.num vertices is equal to init underscore init self is equal to, I need to pass that argument. Just copy it. I don't want to type too much. So number of vertices. Apart from it, what else should have? An adjacency matrix. Self dot adjacency AMAT. That's a shortcut. It should be a list of lists where every list is a row. So this is a list, this is a list, this is a list, and all comes under a list. And by default, everything should be assigned to -1 because I don't know if an edge exists between those two vertices. So I'll just say this -1 into, I'm just assigning means initializing my adjacency matrix for I in range. If this is not clear to you, I'll show it to you right now. Apart from it, I need to initialize my objects, my vertex objects. So for X in range, self.number of vertices, new vertex is equal to vertex, correct? Vertex needs an ID, so let the ID be X for now. And I need to define my list beforehand. Self.vertices is equal to this. Let me copy this. And I will say self.vertices.append the new vertex object that I just created. Correct? So this was an initialization part. Now think about what other functionalities it should have. There should be a functionality to add an edge. There should be a functionality to view my matrix. There should be a functionality to set ID for my vertex. Because right now just set the ID as 0, 1, 2, 3, 4, 5. But I need to set the proper IDs to it. So first, just let's make this line clear to you. So let's just define the print view matrix. Define view matrix self. So we'll use numpy over here. Input numpy as np. Numpy has got something known as matrix function. So I'll say np dot matrix print this particular matrix. So right now everything should be initialized to -1. Print it. Now let's see. Oh, FPR. You should have corrected me. It's for, not FPR. So let's see how the adjacency matrix looks right now. So right now we expect every element should be -1. So let's create an object of the class graph. And we say 5 because we are here having 5 vertices. 1 to A, B, C, D, E. That is 1, 2, 3, 4, 5. So I passed 5 to it. Now let's do G dot view matrix. View matrix. Enter. So if you see, my self.adjacency matrix is right now a matrix where a 5 cross 5 matrix where every element being -1 because I've not added any edge yet. Now with a view matrix initialized, what next? I think the next step should be set matrix, set vertex, where we'll set the edge, the vertex with a particular ID. So how to do that? So let's define a function, set vertex. What will you pass to it? You have to pass an ID to it. Yes. Oh, V should do capital. I follow that convention. So set vertex. So I'll say that, say you have passed a particular vertex. Say like I'll be calling it like this: G dot set vertex 0 with A, because if you see we have A, B, C, D, E, then there should be something like, I'll just copy it. First I define the calling, then I define the function. Char patch. So it will be A, B, C, D, E. Okay. So how will it be? So I need to define. So I'll say I have already a list of all my vertex objects. So that iterate over it for x in range self dot num vertices. That is 5 right now. What will I do? Self dot vertices x. So when I say initialize 0 with A, initialize 1 with B, initialize 2 with C, initialize 3 with D, initialize 4 with E, so I have passed an ID to it, correct? I have passed 2 arguments to it, the vertex and the ID. So I'll say vertex and ID. So if VTX is equal to X, then self dot vertices X dot self dot vertices X is what? It's my vertex object dot set vertex. I defined a function set vertex and I'll pass ID to it. So it will go, say I say G dot set vertex 0 comma A, it will initialize the vertex object at 0 with my ID as A. Pretty cool. If you want to see the vertex now, so let's define a vertex. Just to see if it is properly initialized, we'll define a vertex, a function get vertex. We do a self and you pass an ID. So that will be like A, B, C, D, whatever it will be. So again I'll say for X in range self dot num vertices, if X is equal to ID, print if X is equal to ID, that is, say I passed 0. First let me define it. This will throw me an error because I have not compiled the upper code. Get vertex and I say A. Okay? So I said A. So if X is equal to ID is wrong because X is 0, 1, 2, 3, 4, 5 and my ID is A. So rather I'll have to go through the entire list of objects for X in self dot vertices, my list of objects. So I'll remove this. For X in self dot objects, if X dot get vertex, if X dot get vertex is equal to ID, print X. This looks right to me. Let's check it out. Shift enter, shift enter, shift enter. You got an error. Self dot vertices X Graph has no attribute vertices. You should have corrected me again. Line number is, I don't see the line number. Okay, where is it? FV vertices. Shift enter, shift enter, shift enter. So you see that returned me an object. Now how do I know if it is that same object? So rather than doing a print x, let's do print x dot underscore underscore ticked. Shift enter, shift enter, shift enter. So it did return me the vertex object whose ID was A. Correct? Got it. Now you have initialized your vertices objects. You have initialized the function to get those vertex objects. Now you need to initialize the function to add an edge between two vertices. So I say define add edge. Now this should take three parameters. One is from which vertex, to which vertex, and my count. So initially I'll just put it as 0 if we don't pass it. Now I'm saying that create an edge from this vertex to that vertex. So how will you write it? I'll say g dot add edge. So if I look at my graph, it says create an edge from A to B. Correct? So A comma B comma 1. The weight should be 1. So I'll say that get my vertex whose edge is A. So I'll say adjacency matrix now my x is an object and I'll have to return over here an edge. I say A comma, as I've said over here, A comma B and the weight is 1. Then I have to create an edge from 0 to 1. Correct? So how do we do that? So we'll say add an edge from this to this. So rather than returning print x, what we should return is let's change this guy for x in range. Self dot number of vertices. Okay, and I'll do if self dot vertices, rather than x, I'll do self dot vertices x dot get vertex. Correct? Is equal to id, then return x. Correct? So I'll say that create an adjacency matrix from this to this is equal to count. So rather than from, I need to return self dot get vertex frm. Copy this. So this will return from and to. So self dot get vertex from, so from being A in this case, it will return me, get vertex will return me 0. For 2, that is B, it will return me 1. So it will form an adjacency matrix between 0 and 1. So this is only in case of a directed graph. Say you have an undirected graph. In case of undirected graph, we'll also form a link the other way around. So we'll also say, we'll just copy this line. Don't just form an edge between from and to, but also between to and from with the same weight. But we'll comment out this code because right now we are dealing with directed graphs. So let's run it. Shift enter, shift enter, shift enter. No error till now. Now how does your matrix looks like? If I view matrix, right now the 0 1th column should be replaced from -1 to 1, 0, 1 is 1 if you see. All the remaining items is -1, but I have an edge from A to B that is 0 to 1, which is put as 1. So now if you look back in the graph, you also want an edge from B to D and B to E. So let's just write that. Add edge B to D and B to E. And just do Shift Enter. Oh, I missed this. Shift Enter, and again you view my matrix, and you will see an BD, BE. So AB is 1, then BD is 1, and BE is 1. And if you map it to this, you see slowly I'm getting the same structure. So now you can add edges between vertices, you can view your matrix, you can assign ID, you can assign vertex objects, and this is basically how you represent a graph using adjacency matrix. I think we covered it quite well. Now let's come into the pros and cons. If you view as the space complexity and time complexity of adjacency matrix representation of graph, you can see it's bigger or V square, V being the number of vertices. If you see for a vertex 5, we have a 5 cross 5 matrix representation, and the time complexity of fill is again big of V square. So because every operation takes 1 unit, so to add an edge, so big of V square. Now you'll say that the time complexity and space complexity is really awful. Now, when will adjacency matrix really help you? When you have a really dense graph. If you have a really sparse graph, most of the elements in the matrix will be -1, and most of the space you'll be failing to utilize. So adjacency matrix really fails when you're using a sparse graph, and really works when you're using a dense graph representation. So we'll now look into the adjacency list representation of graph. In the next video, we'll talk about the disadvantage of adjacency matrix and how we can utilize less space to represent our same graph. Okay, see you in the next video. Bye bye.